Hi everyone, Mr. McIntyre here. So far in Module 2, we've been focusing on solving equations, and we did solving one-step equations and then multi-step equations. But today what we're going to do is we want to look at some equations where you have variables on both sides. That's going to be the difference. So what I said just a second ago, we've been solving equations, but one of the things about all the equations I've given you so far is there was just one variable. Like if the variable was x, there was an x somewhere, you had to isolate it. Now today we want to look at some equations where there's still only going to be one variable. Like it's just going to be x or maybe just p or whatever the letter is. But that same variable might show up more than one time in each equation. And that's why I said more than one of the same variable. We're not looking at equations yet that both have like maybe x and y in it or something like that. So our goal is to eliminate one of them. Get it to the point where there's only one variable in there. So there's kind of two things that can happen. If the two variables are on the same side of the equal sign, then what we do is what's called combining like terms. So here's an example of that. Let's say in our equation, we have 2x plus 1 plus 3x equals 11. So you can tell by looking at the problem, this is what I mean. You have more than one x in there. You have this 2x right here and this 3x right here. But they're on the same side of the equal sign. So they're part of the same expression. You can just think of it as 2x plus 3x, and you can just add those together. That's what we mean by combining like terms. So for this question, what I would do, I would just combine these two things together into a 5x. 2x plus 3x is 5x, and then leave everything else. So you still got the plus 1 there, so it ends up being 5x plus 1, and it's still equal to 11. And then you would solve it like the equations from last section. I'm not going to finish this problem, but you would subtract 1 from each side and then divide by 5. So that's what you do when the two x's, or the two variables, are on the same side of the equation. Now, if they're on opposite sides, then what you want to do is cancel them out, just like you cancel out numbers when you're solving. So you want to use inverses to cancel one of them out. So for example, right here, if I had 7x plus 3 equals 2x minus 12, same thing. I have a 7x and a 2x. So I have two different x terms. But see, this time they're on opposite sides of the equal sign. So what I would want to do is get rid of one of them. And it doesn't really matter which one. I usually pick the smaller one. I would take the 2x and say, let's get rid of the 2x. I'm going to subtract 2x from each side. And if I did that, if I did minus 2x and minus 2x, then see what happens is the 2x and the minus 2x cancel, they're gone. 7x minus 2x is 5x, and all of a sudden I'm down to an equation I can solve again. So if I subtracted 2x from each side, what I would end up with is, instead of that 7x, I would have 5x, still have the plus 3 there, equals, now the other 2x is gone, so it's just that minus 12 or that negative 12. And then I could finish solving there. And again, I'm not even going to finish solving this one. We'll do a full example in just a second. I'm just showing you the difference. Now I want to make sure you guys really understand the common mistake is if I go back to that first question, which was 2x plus 1 plus 3x equals 11, the thing I see people do all the time is they try to do what I showed you on this slide to that problem. They go, oh, I have a 2x and a 3x, so I'm going to subtract 2x here and subtract 2x here. And they say this one cancels, I get 1 plus, that would be 1x equals 11. Now see, that's wrong, because the number one rule for equation solving is you have to do the same thing on both sides of the equation. So right here, here's my equal sign. I didn't do minus 2x on each side. I did minus 2x twice on the same side. So my equation isn't equal anymore. I didn't change both sides the same way. So make sure you don't do that. Focus on the two things we talked about today. If the numbers are on the same side of the equal sign, just add them together. If they're opposite sides of the equal sign, pick one of them. Like I said, I usually pick the smaller one. subtract it off, cancel it out, and then you'll only have 1. So let's do a full example. We're going to solve this problem for x right here. We have 2x plus 13 equals 5 times, and then parentheses, x minus 1. So order of operations tells us we have to do the parentheses first. Now, when you're talking about order of operations and doing parentheses first, the first time we did order of operations, there weren't variables, it was just numbers. So if in the parentheses, instead of x minus 1, if it said like 5 minus 1, then just do that. 5 minus 1 is 4. Well, see, we don't know what x is. So we're going to have to do the parentheses a different way. And what we're going to do, we're going to get rid of the parentheses by using the distributive property, which we also learned in Module 1. So let's do this. For this question, let's leave the 2x plus 13, leave the equal sign, but over there on the right, I'm going to use a distributive property. I'm going to take the 5, and I'm going to do, first, 5 times x is 5x, minus 5 times 1 is 5. See, now by doing the distributive property, by multiplying the x and the negative 1 by 5, the parentheses are gone now. And now all of a sudden it looks like the question we just looked at in the last slide. So I have a 2x and a 5x, and remember they're on opposite sides of the equal sign. Maybe I'll draw on that dotted line again just to remind me. Anything I do on one side of the red line, I have to do on the other also. So I want to get rid of one of those. Now for me, I said I always pick the smaller one. So for me, I would subtract 2x from each side. If you subtracted 5x from each side, it's fine, but then you end up with negative numbers. So I like going with the smaller one. I'm going to do a minus 2x here to cancel that. I'm going to do a minus x on the other side of the line. I'll line it up under the 5x. So this one cancels. The 13 drops straight down. 5x minus 2x is 3x, and then the negative 5 drops down. And now all of a sudden we've got it turned into a problem from last section. So now that there's only one x instead of 2, our main problem was I had a 2x and a 5x. We got rid of one of them, now we can solve. So my next step for this problem would be to add 5 to both sides. And I did that here to cancel out this negative 5. I did the same thing on both sides of the line. 13 plus 5, I'm going to move up here over to the side. 13 plus 5 is 18, and 18 equals 3x. So final step, to finish solving for x, I need to cancel out that 3. I'm going to divide both sides by 3. That 3 cancels with that 3. I isolated x, and I got my answer, and my answer is 18 divided by 3, which would be 6. So each day so far of Chapter 2, we've added one thing to equation solving. We started off with solving one-step equations, which is real simple. It's in the title. You do one step and you're done. Then we did multi-step equations. Maybe you have to do more than one step in each problem. Now we've added one more thing where maybe there's more than one x in the question. First step is get rid of one of them because you only want one x in your question. After you're down to one x, then solve it like we did in the multi-step ones.